Chain rule. Chain rule. All right, guess what we are going to learn about today? The chain rule. That's right. Okay, so this is a derivative rule that we have not learned about. So this is called the chain rule. So you're going to think about when are you using the chain rule versus the power versus the product versus the quotient versus your e's and your ln's and all of that fun stuff. And do I ever have a double chain, aka a two chain rule? Absolutely. Okay, so a chain rule here, you're going to see the different parts, and it's basically when you see an inside of a function. So when you've got an inside of a function like a composite function, remember that word? Composite function. That's when I know I'm going to have to use the chain rule. Okay, so if I have, for instance, the inside is some function of u, then I take the derivative of the outside, leave the inside alone, times the derivative of the inside. So here you can see again, there's my inside. I take the derivative of the outside, leave the inside alone, times the derivative of the inside. That's going to be my chain rule. So let's practice seeing some inside and outside. So here, do you see how this inside function is x to the third plus 1, and the outside function is like a radical x? So let's practice. What's the inside function here? 3 plus sine x. And what's the outside function? It's basically if that whole thing was an x, x to the fifth. My inside function, 3x. My outside function, tan x. Okay, so this one, we need to remember how we rewrite that. So that's the same as saying cosine of x to the fourth. So now there's my inside function. There's my outside function. So it's good as you're kind of doing these to know, well, when am I going to use a chain and when will I not? So on this one, you can see, even though it's like 2 1/3, the inside is just an x. So we don't need to do a chain rule. That's just the 3x squared for the derivative. Here, I should have put that down here. Here, I do have an inside. This inside is not just an x. So I do need a chain rule. So I'm going to take the derivative of the outside function. So here you might even rewrite it with the power instead of the radical. So the derivative of the outside function is a power rule. So that's 1/2, leave the inside alone, and then subtract 1. So the inside alone just stays there. So that's the derivative of the outside times the derivative of the inside. And then feel free to reduce as much as you want. Okay. Let's do some more. This one I'm going to need a chain because I have this inside. So I'm going to take the derivative of the outside, leave the inside alone. So the derivative of the outside is just a power rule. Leave that inside alone times the derivative of the inside. And again, reduce as much as you'd like. Okay, this next example looks like you would use the quotient rule, but this is so much easier to use chain. Okay, so this is so much easier. So how can we rewrite this? That's negative 3 times 4 minus x squared to the negative 5. So that's just rewriting my y. And now I can see where chain rule is going to be so much easier than trying to do that low d high minus high d low all over low low. And even when we take the derivative of low, we've got a chain. So we might as well just turn it into this one chain derivative and not have to do multiple things. So here I'm going to take the derivative of the outside, leave the inside alone, times the derivative of the inside. Okay, okay, what about this guy? What that's doing that. Well, on this one, I see two functions. This function I'm going to rewrite into the exponential form instead of the radical. And so I see I have a product rule going on, and I have a chain rule going on. So I've got both. So we're going to take our time when we write this. So my product rule says I'm going to take the first times the derivative of the second. So I take my first times the derivative of the second. So just derive that second piece. So that's a chain rule. Derivative of the outside, leave the inside alone, times the derivative of the inside. So here, this was my first times the derivative of the second. Then I'm going to add the second times the derivative of the first. That's a nice derivative, isn't it? The 2 and the 1/2 cancel. So now this is the second times the derivative of the first. And I've got that plus in the middle. Let's go ahead and see if we can clean this one up. You guys try that. Pause me and see if you can clean it up, and then unpause and see if you get it right. Here, I'll tell you what you should get it to. Oops, that's a cubed. Let's see how we did. I just got opposite sides. So let's just double check this real quick. So we had this negative out in front. Took out an x. That'd be negative x squared over 2. I think I just wrote that backwards when I wrote that on there. Yeah. Okay, so there we go. Double check that. If I messed up, tell me in class. I think I did it. Okay, let's look at this one. Here we go. We have a chain. And on the inside, we have a quotient. So see if you can set up the first step unsimplified. All right, so I'm going to bring down the 3, derivative of the outside, leave the inside alone, times the derivative of the inside. When I take my derivative of the inside, I'm going to say low, d high, minus high, d low, all over low, low. So let's get that simplified. So this part would be 12x squared plus 18x minus 6x squared plus 4. This part would be 2x plus 3 squared from distributing that square. And then I still have over here 2x plus 3 squared. So this inside, it looks like it's going to go to 6x squared plus 22. So I could take a 2 out from there. So that would be a 6 there. Oh, silly, silly, silly. Go back for a second. That's a 4, that's an x. I got it. I caught myself. So those two go together, and then that's plus the 18x, and then plus the 4. Sorry about that. Okay. So now I could still take a 2 out from everything and keep that 6. That's good. But now that would be 3x squared plus, take a 2 out of there, 9x. Take a 2 out from there is 2. Over 2x plus 3 to the 4th. Okay. Let's try this one. What does the 4 get to do? Do I have a product rule? No. Okay, that 4 is a coefficient, so it goes, woohoo, along for the ride. So that 4 just comes on along. Okay, so now over here, I'm going to do my chain rule. So I'm going to do derivative of the outside, and derivative of secant is secant tangent, leaving the inside alone. So derivative of the outside, leaving the inside alone, times the derivative of the inside. There we go. Okay, I am definitely going to rewrite this one here before I start on it. And I wanted, sorry, that was a typo, to find dy dx. So I'm going to rewrite that. This would be pi squared x squared. That's easier to rewrite to doing an inside power rule than to doing a double chain here. Okay, So take the derivative. Remember, we can see separately with pluses and minus, so that's just a 3. The -5, long for the ride. Derivative of the outside, so derivative of cosine is negative sine. Leave the inside alone, times the derivative of the inside. Then I'm definitely going to put this together. So this would be 3 plus 10 pi squared x sine of pi squared x squared. Next. All right. Always rewrite. Okay, when you've got that. So before we do anything. Uh-oh, guess what this one is? 2 chains, you called it. Okay. So the first thing I'm going to do is make this my inside. So I'm going to take the derivative of the outside, leave the inside alone. Now, as I derive this piece, I'm going to make that my inside. So I take the derivative of the outside, leave the inside alone, times the derivative of the inside. Okay. So let's pause for a second and see if there's any way that we can simplify this, because even though this is a wonderful, awesome answer, this may not happen on a multiple choice exam. They may have some other options and you're like, what the heck? I did it all right. So do you remember, come here, colors, this formula right here? If I said the sine of 2 theta equals 2 sine theta cosine theta. So this was back when we did our pre-calculus, we learned this. And I want to use that rule here to see if I can simplify this to just a sine function. So basically, if I think about that, that would be 2, so -5 pi times 2, because I need the 2, sine of the pi t times cosine of the pi t. So instead of theta, I have pi t. Well, the hard part is like this theta part right here. Is just knowing that that's going to be kind of the same thing going on. This is just kind of like a dummy variable. I could put anything in here, and no matter what that is, when I put it into the sine, I just double it. So this part right here is matching what I need for my formula. So I'm going to take and leave my -5 pi, and then I'm going to do this formula part is going to become sine of 2 times that theta, so times that pi t. And that could definitely be an answer on the multiple choice that we need to get it to match. Okay, I love it when it's just in terms of F's and G's and stuff like that. I think everything makes so much more sense of just kind of really seeing what you're doing. So here I see that P of X is F of X squared minus X. So I can see the composition. Here's my inside, my outside function is F of X. It wants me to find the slope of the tangent line. So in order to get the slope of the tangent line of P, I need to find the derivative of P. So when I find my derivative of P, I'm going to have to do the derivative of the outside, leave the inside alone, times the derivative of the inside. So then it wants me to plug in a -1. So -1 squared is 1, minus a -1 is +1, so this would be f prime of 2, times 2 times -1 is -2, minus 1 is -3. So then I'm going to go to the f prime of the 2 and see that this is 5 times -3, which is -15. Ready to level up? Oh, I know you are. Here we go. What is this one? You called it. It's a 2-chain. Okay, so let's take this derivative. Here, I'm going to just rewrite f of x. So when I take my first derivative, this is the inside. So I take the derivative of the outside, leave the inside alone. Now, as I take the derivative of the inside, I have another inside-outside. So now I take it times the derivative of the outside, leave the inside alone, times the derivative of that inside. Then we want to go plug in 1. So that would be 3 times g of 1 squared is 1, times g prime, 1 squared is 1, 2 times 1 is 2. And then I go look at my graph. G of 1 is 5, g prime of 1 is 3. And then simplify it as much as you need. Okay, why don't you guys try this next one on your own? See how far you can get. So pause me, and then after you've tried it, go ahead and unpause. So this is what I got. I had a 2-chain, derivative of the outside, leave the inside alone, derivative of that outside, leave the inside alone, times the derivative of that inside. Now I know that I am looking for h prime of 1.5. Or I like to do fractions, 3/2. So this would be f of 2 times 3/2 is 3, times f prime of 2 times 3/2 again is 3, times the 2. So what else do I know? I'm only given g and g prime over here. I'm not given the f's. So what do I know? They told me that f of 3 is 2. So I know I can go plug that in. What about f prime of 3? Well, all they told me is what f prime was. So f prime here is this function. So if I want f prime of 3, I'm going to have to find, plug in the 3 to this function. So now I can go find g prime of 2, and I see that's -3. Times the 2 would give me -6 times the 3 right there. So let's see, -18 cosine of e to the third. Okay, 3 more left to try. So here is h of x, and it tells me it's a composition function. So f of g of x would be, plug everything in for g of x into that x. So it would look like that. So now I can see that I have a chain and I have a quotient. Derivative of the outside, side alone, low, d high, minus high, d low, draw the line and square below. So let's see what this simplifies to. This would be x minus 1 minus x, so just -1. So I can just put a -1 there. So let's go see which one it is. Oh, holy moly, I didn't even have to simplify. I went too far. I should have stopped here. And I see that that answer was, I see that that answer is C. Okay, I really want you to try these last two on your own. I'm going to tell you the answer and see if you can get to them. But this one is C. And this one is D. And if you need help, let me know. I'll help you once we get into class. All right, kiddos. See you soon.